must go from denser to
denser to rarer medium.
rarer medium, and the angle of incidence must be greater than the critical angle.
Yes, sir.
That is the condition for the total internal reflection. And if someone is asking what is critical angle, then you will say the angle of incidence for which the angle of refraction becomes 90 degree, or you can say the refracted ray is grazing the surface or moving along the surface. You can say this is a
Yes.
refracted ray and this refracted ray is moving along the surface. Okay. So this is the total internal reflection. Here the angle of incidence is greater than the critical angle. So
Yes,
now
sir.
here the reflection is taking place, reflection. So if reflection is taking place, then you can say this angle must be equal to this angle. Angle of incidence must be equal to
Angle
angle of
of reflection.
reflection. Okay.
Yes.
So now we will calculate the critical angle. Okay, we will calculate critical angle. So these are the condition: light should move from denser to the rarer medium. Angle of incidence must be greater than the critical angle, and calculation of the critical angle. Now we will calculate the critical angle. Okay, let's see. So light is going from denser to the rarer medium.
Yes, sir. Yes, sir.
Okay. If this angle of incidence I, if uh, this angle of incidence I is equal to the critical angle, okay, if this angle of incidence is equal to the critical angle, then what we can say? Hmm, what we can say? If this is a critical angle, so the refracted ray will be like this, move along the surface.
Yes, sir.
So the refracted ray will be like this, will move along the surface. Okay. So if refracted ray is like this, so angle of refraction becomes 90 degree. Angle of refraction becomes 90 degree.
Yes, sir.
Okay. Okay. And we want to calculate this angle, means I, or you can say C angle if we want to calculate.
Yes, sir.
So here na, we will apply the Snell's law. We will apply Snell's law.
Snell's law.
Yeah. Snell's law. So I told you that we apply Snell's law between two media. Okay. So how we will apply the Snell's law? First, choose any of the medium. So I choose the denser. Light is going from denser to the radium, so you can choose just
Yes, sir.
denser medium. So first you will write the refractive index of the denser medium and multiplied by sine of angle with normal. This is the normal. Okay. Then refractive index, that is mu
Yes,
2,
sir.
and sine of angle with normal, that is sine I. Okay, is equal to refractive index of another medium, that is mu 1, multiplied by sine of angle with normal. What is sine of angle with normal? Sine 90. Okay, sine 90. So now put the value. This is mu
Sin
2 and
90.
sine I is equal to C. We will put I is equal to C. Okay, so this will be sine of C, and this is equal to mu 1. Okay, uh, mu 1 multiplied by sine 90 is 1. Okay, sine 90 is 1. So sine of critical angle is equal to mu 1 divided by mu 2. What is mu 1? So
Mu 2.
you can write the sine of critical angle is equal to mu
The
1.
refractive index of
Right, right.
yes.
Refractive index of rarer medium.
Yes,
Refractive
sir.
index of
Rarer medium.
rarer medium divided by the refractive index of denser medium.
Denser medium.
So mu 1 by mu 2. So remember this formula. Okay, remember this formula. This formula you should know. So critical angle for two surface or critical angle for two media is equal to refractive index of the rarer medium divided by the refractive index of the denser medium.
Denser medium.
Yeah. Okay, so we'll solve this question. Okay. So they are asking find the critical angle for air and the glass interface. Okay, critical angle for air and glass
Yes, sir.
interface. So in air and glass,
Glass interface.
what is rarer and what is denser? So air is the rarer and glass is the denser.
The air is denser, yes.
Okay. So this air is rarer and this glass is denser. So we can find the critical angle. We have the formula of the critical angle. Sine of critical angle is equal to refractive index of rarer medium divided by refractive index of denser.
Denser medium.
Yeah, denser. So sine of critical angle is equal to refractive index of rarer medium here 1 for air na, and refractive index of denser medium, that
Yes.
is refractive index of glass, that is 1.5.
Yes, sir.
Okay. So it will be 1 divided by 1.5 can be written as 3 divided by 2. So you can write it as 2 by 3. So you will get sine of critical angle is equal to 2 by 3, and this value of critical angle you will get sine inverse 2 by 3. Sine inverse 2 by 3 you will get. And this value, okay, this sine inverse 2 by 3, if you will write this answer, then it will be correct. If you will write this answer, then it will be correct. Okay.
Correct.
There is one question, and that this question I think I will say this is a good question. This question. So first we should remove this. Okay. Now see this question. This is a glass. Okay, this is the glass medium, and here is the air, and they are asking complete the path of ray. Okay, complete the path of ray.
Ray.
Complete the path of ray. Okay. Uh, and it is given that the critical angle for the air glass interface is 42 degree. This is given. You can say here. C is the critical angle, and this critical angle is given for
Yes,
the
sir.
air and glass interface. So now we will see in which direction this ray will go. So this is the incident ray. Okay, this is the incident ray. So we are just solving here. We will solve this here. So this is the incident ray. Here is glass. So as the light ray is moving from the rarer medium to the denser medium. So this light ray, incident ray is moving from air is the rarer medium, glass is the denser medium. Okay.
Denser
So
medium, yes, sir.
this ray is going like this. So at this interface, either there will be the refraction or either there will be the reflection. Okay, so what we will do, we will draw the normal. We will draw the normal. Okay, so draw the normal. So this, suppose this is the normal here. This is the normal. Okay, and this is the normal. So what is the incident angle? What is the incident angle? Angle of incidence? This angle.
9. Oh, yeah.
No. 90 minus 42. That is 48.
Yeah.
Angle of incidence
Yeah.
will be 48 degree.
48.
This
Yes.
48 degree.
90
Now
minus
you can
42.
90 minus 42, because this whole angle is 90 degree. Now just notice one thing. Critical angle is 42 and angle of incidence is 48. So here what is happening? Angle of incidence is becoming greater than the critical angle.
Yes, sir.
So now, and see this light ray. This light ray is in the denser medium right now. This light ray is in the denser medium and is just going towards the
Yes,
rarer
sir.
medium. Means you can say what are the conditions for TIR, total internal reflection? Light ray must move from denser to the rarer medium. So you can see here that this light ray is in the denser medium and going toward the rarer medium. Another point, angle of incidence must be greater than the critical angle. So angle of incidence is 48 degree and critical angle is 42 degree. So that is greater.
42.
So here total internal reflection will take place. Total internal reflection will take place. So the path of the light
Yes, sir.
ray, the path of the light ray will be supposed like this, because here TIR will take place. Okay, because TIR will take place. Okay, and this angle will also be 48 degree. This angle will also be 48 degree. Why? Because angle of incidence is equal to the angle of refraction. Angle of incidence is equal to the angle of refraction. Now after this, here at this interface, see what will happen. At this interface, see what will happen. So again we will draw the normal here. Again we will draw the normal. So this is the normal. Okay, this is the
Yes.
normal. So this light ray is in the denser medium right now, and it is going to into the rarer medium. Going into the rarer medium. So we want to find what is the angle of incidence. Means this angle. If we got this angle, then we can easily predict the direction of the incident ray, direction of the ray. So now see, this line and this line are parallel, and this angle is 42 degree. So this angle will also be 42 degree, because these are the
Yes, sir.
alternate angles. These are the alternate angles. On in other way also you can just find this angle. This angle is 42 degree, and you can take this triangle. You can take this triangle, and this angle is 90 degree.
Yes.
This
And
angle
then
is 90
alternate
degree.
internal angles.
90 degree. So you
Yes.
can find this angle. When you will find this angle, you will get 48 degree, and when you will subtract that angle from 90,
Yes.
you will get 42 degree. So now what is the angle of incidence here in this case? Angle of incidence here is 42 degree, and here angle of incidence is becoming, here in this case angle of incidence is becoming equal to the critical angle. So there will be the grazing emergence, means the light ray will travel like this. The light ray will travel like this, means along the surface the light ray will travel. So this is the final path of the light ray. Okay, final path of the light ray,
Yes,
and
sir.
angle of incidence is greater than the critical angle is happening here, and here the angle of incidence is becoming equal to the critical angle. So there are two conditions here. So this is the final path. Okay, so you can just note down. Hmm.
So guys, hold on.
After this, na. So if suppose the radar medium is the air, okay. If
Yes.
radar medium is air, so if radar medium is air, then the critical angle will become refractive index of the radar medium, and refractive index of air you will put, and that is equal to 1.
One.
So, huh? So
Yes.
this formula you will get. If radar
One,
medium
right?
is air, yeah,
Yeah.
1 for the air. So this is for the air, and refractive index of another medium is mu. So critical angle will become 1 upon mu. So at this point also.
Done, sir.
Okay. Harsh completed this one.
So just done, sir.
Okay.
Done, sir.
Okay. So write down this question. First, write down this
Okay.
question, and after that, separately draw this diagram. Okay. Otherwise, you will get confused.
Okay.
Okay. First, write down this
Okay,
question.
sir.
Huh.
Done, sir.
Okay, so we'll discuss now prism. So what is prism? This is prism.
Yes, sir.
See this. See this diagram. So basically, a prism is solid. Have you seen prism in your school lab?
Yes, sir. Yes, we have done the experiment.
You have done the experiment to find the, I think,
The position
min
needles.
yeah, minimum
Yeah.
angle of deviation, I think,
Yes, sir. Yes,
that
sir.
was the. We will also just drive that here. So basically, a prism is a solid homogeneous. What is the meaning of the homogeneous? Throughout the
Throughout limits
prism,
throughout. Yes.
throughout the prism, the material is same. Okay, refractive index is constant throughout the material. Prism is a solid homogeneous and refracting medium bounded by two plane surfaces inclined at some angle. Now you can see this is basically in prism. Uh, One plane surface is this, another plane surface is this. This is like this. Okay, one plane surface is this, another plane
Yes,
surface
sir.
is this, and in between these surfaces means these plane surfaces are inclined to some angle, and that is known as the angle of the prism. Okay, so this is the refracting surface and this is a refracting surface, means this is a refracting surface and this is a refracting surface.
Yes,
Okay,
sir.
okay, I am not saying refraction cannot takes place from this surface or this surface, but we are considering the refraction from this surface and this surface. Okay, so we are only
Yes, sir.
focusing on the two surfaces like this. So A is known as the angle of prism, and when you will see this prism from the front side, so this prism to you will look like a triangle. Suppose you are standing here, and you are observing this prism from the front. So this prism will look like a triangle, is it or not?
Yes, sir. Yes, sir. Yes.
Look like a triangle. So this prism will look like a triangle. So this is a reflecting surface. This is also a reflecting surface, and this is the angle of the prism. And this is the front view of the prism. This is the front view of the prism. So basically, for the derivation, other derivation that will come in the topic prism. So we will draw the prism like this. But in actual, the prism is this.
Yes,
So
sir.
because you already seen the prism in your school lab, so no problem. That means you can understand that. Now, angle of deviation. Angle of deviation we will discuss. What is the angle of deviation? This is a prism. Okay, this is a prism,
Yes, sir.
and this prism is having the angle of prism A. So what is A? A is the angle of prism. A is the
Angle of.
angle of prism. Okay, no problem. This is a prism, and this is the incident ray, and around the prism there is air. There is air around the prism. Okay, this is the incident ray. So now, as this incident ray is moving from air to the this prism is basically generally this prism is made up of glass, and as compared to the
Yes.
air, the glass is a denser medium. As compared to air, the glass is a denser medium. So this is the incident ray. This incident ray is moving from rarer medium to the denser medium.
Dense medium. Yes,
Huh.
sir.
So refraction will take place from this surface. This surface, okay? This surface. I told you na the two surfaces are there. One is this and one is this. So from those two surfaces, the suppose this is the first surface. Okay. This surface is the first surface, and this surface is the second surface. I am just assuming it. Second surface. Second surface. Now this is a incident ray. So for showing the refraction, we will draw a normal. So this is a normal, suppose. This is a normal, and is the normal. This is normal. So now you can see this is the incident ray, and this is incident ray is going from rarer to the denser medium. It will bend away from the normal or towards the normal.
The air denser, it will bend away, right?
No, 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 no.
No, it's towards
It
the normal. Yes,
towards the
rare
normal,
denser.
because this ray is moving from rarer to the
Denser,
denser. So
rare denser.
it will bend towards the normal. Suppose you can say like this. Okay, this is bending towards the normal. If you will want to show the path of the ray,
So
if
just
there is
some, I think my network is lagging.
hmm,
Sir, I think someone's network is lagging. Can you check yours? I'll check mine.
it's fine from my side. Hello, Harsh.
Yes, sir, yes, sir.
From
Sir,
your
I
side,
it's
it's
my
okay.
show, sir. Yeah, no,
Uh,
it's
from my side, I think it's okay.
yes, sir. You can continue, sir.
Means my voice is audible. Means it's fine, na?
Yeah, voice is like it's audible, but it's lagging. Like it's coming to
Lagging.
me late.
Okay. Just I checked
And
my
my voice
internet.
is my voice is also reaching late to you.
Yeah, your voice is little bit lagging. Little bit.
Yeah.
Okay, so okay, what can we do now? Should I start?
So you can continue, sir. We'll see, sir. Yeah, you can.
Okay, so this is the incident ray, and as this ray is moving from rarer to the denser medium, it will bend towards the normal. So this will be the path of the light ray. This will be the path of the light ray. Okay. Now, after that, from this surface, the refraction will take place. From this surface, the refraction will take place. So for that, we will
Yes.
draw the normal again. We will draw the normal again. So I am drawing the normal here. This is the another normal. Suppose this is normal N1 and this is normal N2. Okay. So the this time, can you tell me this ray of light will move away from the normal or towards the normal?
So towards the normal, right? If it's rare or denser rate.
No, no, it is this time this ray of light is going from denser to the rarer. So it will
Yeah,
go
so it is going denser to denser to the away from the normal.
away
If
from the normal like this,
yeah,
okay?
if it's denser to rare, then
Away
it's away from
from,
the normal.
huh, yeah. So this is the angle of incidence, and this angle is known as the angle of emergence. What is I? I is the angle of incident, and E is the angle of emergent. Okay, we want to find the angle of deviation. So see what is the deviation means. This is the path of the ray initially and this is the path of the ray finally. So finally the light ray is going like this. Okay, finally the light ray is going like this. Harsh, are you getting
Yes, sir.
the
Yes, sir.
voice
Yes,
proper?
yes. I'm getting it.
Okay, otherwise, okay. So, okay, if suppose there is no prism in between the incident ray, so this incident ray will go like means straight.
Yes, sir.
Huh. Okay. So I am telling you what is the meaning of the deviation. What is the meaning of the deviation? So this is the path of the ray when there is no prism. Okay. And finally, where the light is going, uh, in this direction, light is going. So we will produce this ray in backward. We will produce this ray in backward like this. like this. Okay. So angle of deviation na, is this. This angle is known as the angle of deviation. What deviation means? This angle of deviation shows that how much degree the light ray is getting deviated.
Deviated.
Yeah. So angle of deviation is represented by del. So del is the angle of deviation. Angle of deviation. Angle of deviation. And this ray, this is the incident ray, and this ray is known as the emergent ray. Emergent, because this is emerging out from the prism. So we can say this is the emergent ray. Emergent ray. Emergent ray, okay. So this angle of deviation we want to calculate. Okay, this angle of deviation we want to calculate. So this is the angle of incidence. So now we can show here, this is the refracted ray. This is the refracted ray for this incident ray. This is the refracted ray. So suppose this angle is R1, angle of refraction, and
Refraction.
you can suppose this angle as R2. And now for this surface, this ray is the incident ray. So this R2 will be the angle of incidence for this surface, and E is the angle of refraction for this surface. Okay, and this is the angle of prism. Now what we will do? See. We want to find this angle of deviation. Okay. See, what we are studying means, what is the name of the chapter? Geometrical optics.
Geometrical. Yes.
So obviously geometry will be used. So you should ready for that. So now this whole angle, this uh, this angle means, if I am talking about, this is a normal, no? This is a normal.
Yes, sir.
And if I am talking about this whole angle will be I, because uh, these are the vertically opposite angles. Okay, these
Yes,
are
sir.
the
Vertically opposite.
vertically opposite angle. If this whole angle is I, then what will be this angle? I minus R1.
Yes, sir.
So we can write this as I minus R1. Okay, no problem. So this angle will be angle of incidence minus R1. Here also, this whole angle is the angle of emergence, because this angle and this angle vertically opposite angle. So if
Yes, sir.
I am talking about only this angle, so this angle will be E minus R2. E minus R2.
R2.
Huh. So this angle will be E minus R2. E minus R2. One more property of triangle will be used here. Now, suppose this point as O, and this point as A, and this point as B. So see the triangle OAB. So triangle OAB. See the triangle OAB. So when you will see the triangle OAB, so this delta or del is the exterior angle, and I minus R1 and E minus R2 are the interior angle. And in a triangle, the sum of the opposite interior angle, these are the opposite interior angle, these are the interior angle, and this is the exterior angle. In a triangle, exterior angle, that is delta, is equal to sum of the opposite interior angle, means this angle plus this angle. So you can write delta is equal to this plus this, means I minus R1 plus E minus R2. Okay, I
Yes,
minus
sir.
R1, E minus R2. So delta can be written as I plus E minus of R1 plus R2. Okay, so this we can write for the delta. Okay, delta can be written like this. Okay,
Yes, sir.
okay, now This is suppose equation number 1. This is suppose equation number 1. After that, what I am doing, I am joining both the normals. I am joining both the normals. So little bit construction we have to do. So don't worry for that. With
Yes, sir.
practice, you can do that. Okay. So normal is going like this normal, and another normal is this, and this normal is going like this. Both the normals are meeting here. Suppose this point is P. This point is P. Okay. Uh, now see this triangle PAB. Triangle PAB. So this angle is R1, this angle is R2, and we know that sum of the angles of a triangle is 180. So this angle will become 180 minus of R1 plus R2. Okay,
Yes,
this
sir.
angle will become 180 minus R1 plus R2.
Plus R2.
Huh. After that, again geometry will be used again. So suppose this is Q, point Q. So now there is a quadrilateral QAPB. QAPB. So you can write here in quadrilateral QAPB. Now quadrilateral, there is a triangle. Triangle means uh, a figure having three sides. Hmm?
Yes, sir.
In triangle we have three sides. In quadrilateral there are four sides, like square, like rectangle, like parallelogram, like rhombus. These all have four sides. So that is why these are known as the quadrilateral. Quad means four. Tri means three. Means three. Okay. So see this quadrilateral, and one more thing here. Na? Here you have to remember one more thing. This angle A is 90 degree. Angle B will also 90 degree. Why? Why? Because this is the normal. This is
Yes,
the
sir.
normal, and this is the normal. So for this, with respect to the quadrilateral, you will take the angle. So angle A and angle B both are 90 degree. So you can write angle A is equal to angle B is equal to 90 degree. And what is the angle Q? Angle Q is equal to A. So angle Q is equal to A. And what is angle P? See, angle P is
P.
equal to 180 minus R1 plus R2. Okay. Now, after this, what we will do? Can you tell me what will be the sum of angles of quadrilateral? Means in case of the triangle, the sum is
Yes, sir.
180. I am saying in case
180, right?
of the
Yeah.
in case of triangle, the sum of all the angles is 180 degree. But in case of quadrilateral, can
180.
no. In case of quadrilateral, the sum of the angle is 360. Remember, quadrilateral
360,
means
right?
suppose,
Yeah.
huh,
And 180 is
suppose
triangle.
yeah, suppose you have the square. This is a square. So this is a
Yes.
quadrilateral. So all the
Yeah.
angles of this
90 plus 90 plus
90,
90 plus 90.
huh, always equal to.
360.
So yeah, this will be 360. So this is not a square, but this is a quadrilateral. So sum of all the angles of quadrilateral is equal to 360 degree. So you can just write down this angle A plus angle B plus angle C plus, oh sorry, not angle C, angle A, angle B, angle C, angle P plus angle Q is equal to 360 degree. Now what is angle A and angle B? Both are 90 degree. This is also 90 degree. This is also 90 degree plus angle P is 180 minus R1 plus R2 plus angle Q is angle A. Okay, angle Q is angle A. This is equal to 360 degree. Now this 90 and 90 will become 180 degree.
Yes, sir.
This 90 and 90 is 180, and this is 180, and this is another 180, and 180 and 180 is 360. Okay, so this 360 will be cancelled out with this 360. So you can write like this. This is 360 na? Minus R1 plus R2 plus A is equal to 360 degree.
Yes, sir.
Huh. So this 360 is cancelled out with this 360. So what you will get, the angle of the prism A is equal to R1 plus R2, because this is the minus. So when it will go here, means right side, it will become R1 plus R2. So angle A is equal to R1 plus R2. Suppose this is the equation number 2. So now this, we have this equation. We have this equation of the deviation, equation of the deviation. Now, Harsh, the voice is clear now?
Yes, sir. It's clear. Sometimes like it's fine.
Yeah, okay. So now del is equal to I plus E, uh, A. A is this R1 plus R2. Okay. So
Yes, yes,
R1,
sir.
R1, R1 instead of R1 plus R2, we can put A. So minus A we can put. So this formula we is for calculating the angle of the deviation. Okay. Angle of the deviation can be calculated with this formula. Angle of deviation. So if for a particular incident ray, the angle of deviation is given by the, you should know angle of incidence. What is the angle of incidence? And what is the angle of emergence? And what is the angle of prism? So I plus E minus A, you will get the angle of deviation according.
Deviation.
And I told you what is the significance of angle of deviation is by how much amount the incident ray is getting deviated through the prism. That is the significance of angle of deviation. Okay, so now you can write down and draw the, just try to draw the figure. Means I'm just increasing the
Yes.
size, just increasing the size of it. Is it fine now,
Yes, sir.
or should I zoom more in?
No, that's fine.
It's fine now. So all the angles are. So Harsh, in your exam, na, they can ask this derivation also.
Yes, sir.
How drive the expression for the angle of deviation. So here na, in this derivation, basically there are the concept of some of the concept of the geometry you have to understand properly. Otherwise, there is nothing in this derivation. Hurts, to which team you were supporting? Hello, Harsh.
So did you ask
Hello.
something? Sir?
Hmm?
Did you ask something?
I actually I was asking to which team you were supporting.
In FIFA World Cup in France, sir.
Okay.
Sir, I think France deserved to win that. So
Yeah, but actually I have never seen this kind of match earlier.
no, sir. Like last season, I've seen so many matches like that. I'm a Real Madrid fan, right? So every Champions
Oh,
League
oh,
thing, I saw that match,
okay.
like against PSG, against Chelsea, against City.
But na the final match na means is very fabulous. Mm.
Yeah,
Due to
like
due
last
to
season, I experienced it all in every game. Like last 1 minute, 2 goals. Last 1 minute, three
yeah,
goals.
yeah,
I saw that everything.
yeah.
So it was like nothing new to me. I knew that they would score, but
Actually, I think that that match is between Argentina and Mbappe.
yeah, like it was Argentina and Mbappe. Like they were missing their main players, Pogba, Kante, and all those guys.
Mm,
Yes, hold on, sir.
yeah.
Now we're back to club football.
Mhm. You should highlight actually two formulas. One is this and one is this also.
Yes, sir.
A is equal to R1 plus R2. So two formulas. And what's most important is this, and less important, I will say this. This is also important, but less important as compared to this.
Sir, you were supporting Argentina.
Yeah. I was supporting and I was very happy. I am
No,
very
no,
happy.
like the first decision was unfair, so that was not a penalty.
Mm,
Done, sir.
okay. Okay, no problem. Life is also a game. So someone wins and someone lost. No problem.
Oh yes, sir.
The person is losing today or maybe win tomorrow.
Yeah, next World Cup or for
Yeah.
Euros
Yeah.
2024.
Yeah. Okay. So we will solve one question on this. So remember, that question is based on this formula and this
Yes,
formula.
sir. Yes, sir.
And remember one more thing here, na, Snell's law is very important. I told you that in case of the refraction, uh, Snell's law will play a very important role. Okay, so you can see most of the question we will apply the Snell's law. Suppose this is the
Yes.
question. Uh, in this question, what is given? Just a minute. Huh. In this question, there is a equilateral prism. Equilateral prism means the angle of the prism is A, and this A is equal to 60 degree. Equilateral prism means all the angles. Equilateral triangle. Do you know equilateral triangle?
Yes, sir. All angles are
So
equal. All sides are
huh,
equal.
all angles are equal and all sides are equal. All angles are equal to 60 degree. So this angle will also be 60 degree and this angle will also be 60 degree. But there is no requirement of these angles, so we are not considering this. Okay. So angle of prism A is 60 degree is given. This is this thing we know. Okay. So now this is the incident ray, and this is the angle of incidence is given. Angle of incidence is now your internet is fine now.
I think. Yeah.
Okay. So we have to find E. E is the angle of emergence and angle of deviation we have to find. Okay. Angle of emergence. Okay. So this white color is representing the question and green color is the solution. Okay. Green color is the solution. Okay. So and mu is the refractive index of this prism. Root 3 is the refractive index of this prism. So now angle of deviation we want to find, and what is the formula of the angle of for calculating the angle of deviation? Del is equal to angle of incidence plus angle of emergence minus angle of prism. But we have this angle of incidence, we have angle of we have angle of incidence, we have angle of prism, but we do not have
Yes.
angle of emergence. So they are also asking what is the angle of emergence, and if we are getting angle of emergence, then we can calculate the angle of deviation also. Okay, so see what we will do for that. We have to do some. Okay. Uh, Now this is a normal. So as the
Mm.
light ray is moving from rarer to the denser medium, it will bend towards the normal. It will bend toward the normal like this. And one more normal I am drawing here for showing the refraction on the another surface. Okay, so this is the another normal N2, and in this case the light ray will bend away from the normal like this. Okay, this in this case the light ray will bend away from the normal, and this angle will be the angle of emergence E. Angle of emergence E. And what I told you, this angle was R1 and this angle was R2 earlier. Okay, and we know there is a relation. We know there is a relation that I told you later. First what you should do, this is the first surface of the prism. This is the
Yes,
first
sir.
surface. So on this first surface, first apply Snell's law. Oh, first surface we will apply first the Snell's law. First surface, Snell's law. Snell's law. Okay, so what is how to apply the Snell's law? I told you that here the refractive index of the air is 1. Okay, so just light is going from air to the glass, air to this medium, air to this medium. So how we will apply the Snell's law? First, we will take the refractive index of the medium and we will multiply the sine of angle with normal. Can you tell me what will be the Snell's law here?
Snell's law
Means first we will take the refractive index 1 of this medium and then we will multiply the sine of angle with normal, that is sine 60.
Yes, sir.
This is equal to
Now
refractive
refractive index to
root 3
like root 3 into
multiplied by sine of r1.
sine of r1.
Sine of r1. So from this equation we can calculate the r1. So sine 60 is root 3 divided by 2 and here is the root 3 already and we have sine of r1. So this root 3 and root 3 is cancelled out. So we will have sine of r1 is equal to 1 by 2.
1 by 2.
So 1 by 2 is sine of 30 degree. So r1 you will get 30 degree. R1 you will get 30 degree. And one more, one formula I told you that angle of prism is equal to R1 plus R2. Okay, angle of prism is given as 60 degree. R1 is 30 degree. Now from here we can find R2. What will be the value of R2? Just tell me.
R2 will be it's 30 degrees, right?
Yeah, very good. R2 is 30 degree. Now R2 is 30 degree means this angle is 30 degree. This angle is 30. Now what we will do, suppose this surface is the second surface. Now we will apply the Snell's law on the second surface. We are applying now Snell's law on the second surface. Second surface Snell's law. Now how we will apply the Snell's law? Refractive index of this medium. You can choose any medium. I am not saying you can, because light is going between two medium, you can choose any of the medium. Okay, you can choose any of the medium and you can apply the Snell's law. So light is going from this medium to this medium means this medium to this medium means here is the air having the refractive index of 1. So you can apply the Snell's law. You can choose any medium. Suppose I am choosing first this medium, then this medium. First I choose this medium. So I will write the refractive index of this medium multiplied by sine of angle with normal. That is sine R2. Means root 3 into sine R2.
Yes.
Root 3 into sine of R2 is equal to refractive index of another medium, that is 1 into sine E. 1 into sine E.
Sir, you're lagging, sir.
90 degree, so we can put I don't know what the internet is doing today. Just wait. Hello.
Hello, sir.
Now,
No, I think it's fine. I
so
mean,
we
it's
are,
bad, but it's fine.
but it's bad. Okay. So second surface. Okay, we are applying the Snell's law. So root 3 into sine of R2. This is R2, na?
Yes. Yes, sir.
And this is sine of angle of incident emergence. This is the refractive index 1. So in the next case, you will write 1 into sine E. 1 into sine E. So R2 we know sine R2 is sine 30 degree. Okay. And this will become sine E, because you will multiply this with this, it will become 1 only. So this is root 3 now. Here is root 3, and this is the what is the value of the sine 30?
Sine 30 is 1 by 2, right?
1 by 2. Yeah, very good. Sine E. Now can you tell me the value of angle of E?
Angle of E.
So it will become root 3 by 2 na here.
Yes, yeah.
And
It will be root 3 by 2.
so sine E. So can you compare both the values, and can you get the value E? Trigonometry. So okay. So I am telling you how to.
Root 3 by 2 is sine nice. 40,
No, 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 no.
60.
Yeah, 60.
60.
So you can write sine 60 is equal to sine E. Now,
Sine will get cancelled, right?
no, we cannot cancel that, because sine is we cannot cancel, but we can compare. So if you
Yeah,
will
we can.
compare, na, so this E angle will become equal to 60
Yeah,
degree.
yeah.
So
Answer is
angle of emergence you are getting 60 degree.
60 degree.
Now you can find the deviation, that is I plus E minus A. Okay, I plus E minus A. So now you have angle of incidence 60 degree.
Yeah.
Angle of prism, you have angle of prism. What is the value of the angle of prism? A. This is
A.
also 60 degree,
Yeah. It
because
is
this is the
60 plus 60 minus 60.
what is the answer? 60
60.
plus 60 minus 60.
So
The
120
limit
minus
of that.
60.
Yeah, 120 minus 60 means 60.
60.
So it will be 60 degree. So angle of emergence is 60 and angle of deviation is also 60. What is the meaning of angle of deviation 60? Means the light is getting deviated,
By
incident
60
ray is
degrees.
getting 60 degree.
Yes.
I don't know, means whether my internet is going giving the trouble, or it's yours. I don't know what is happening today. Sometimes I think my internet is giving trouble, and sometimes it's yours. Harsh, are you listening me?
Yes, sir. Yes, sir. I mean, it's lagging, but I can listen. Second, scroll down. Again, scroll down.
Done. Completed, Harsh? Hello? Harsh? I think. Hello?